Let's dive into a huge puzzle. How can we share one world but each live in our own?
This quote really gets at it. We're in this together, but our experience is totally unique.
So how does that even work? Well, it all comes down to two cornerstones of cognition.
First up, there's a hidden geometric blueprint inside all our brains, a shared one.
It's called relational coding. You can think of it as a shared map of how concepts relate.
The pattern is the same for all of us, but your brain's specific activation is totally unique.
It's kind of like a constellation. We all see the same star pattern, just from different angles. This invariant geometry is the key. It's the structural necessity that lets us share a reality.
Okay, cornerstone number 2. Our brains are hardwired to keep things stable. Why? Competence is soothing.
Ever wonder why it feels good when things just click? That's your brain rewarding itself.
We actually see a great model for this in AI, in a system they call IGPO. It's pretty wild. The AI literally rewards itself for getting more certain, an intrinsic reward.
And guess what? Our brains do something very similar, and it's all managed by dopamine.
Dopamine helps tune what we forget. This keeps our memory managed and our minds focused.
So just maintaining that feeling of balance is the reward. That's why competence feels so soothing.
All right, let's put it all together. How do these two cornerstones build our very minds?
Well, any big decision, what we call our policy, needs that stable foundation to even work.
So you have the geometric necessity for the blueprint and the intrinsic reward to maintain it.
And this structure has to hold up, even with all the constant learning and forgetting we do.
So if we're all built on this shared plan, what does that really mean for us?
All right, let's jump right in. Today, we are going to unpack a really cool idea that connects neuroscience, AI, and even the way we think about reality itself. We're calling it the geometry of truth. It all kicks off with this kind of strange saying, right? It hints that we can all agree on something, share a common story, but that our own personal take on it will always be unique. So how can both of those things be true? And that's the first big piece of our puzzle. I mean, we all agree a chair is a chair. We live in a shared world with shared rules. And yet, you know that no two people experience that world in the exact same way. So what's actually going on there? What's the mechanism? And then there's the second piece. Have you ever noticed that feeling, that deep, almost quiet satisfaction when you finally master a skill? That feeling of soothing competence? Well, it turns out that's not just some psychological quirk. It's actually a fundamental reward signal that's hardwired into complex systems, both in us and in AI. So today, we're going to connect these two big ideas using some pretty incredible science. Okay, let's dive into this. To get a handle on our shared reality, we've got to first look at how our brains literally build a map of the world. The answer seems to be in a concept called relational coding. Think of it like this. Your brain doesn't just store a picture of a cat and a picture of a dog. What it really does is map out the relationship between them. You know, how they're similar, they're both four-legged pets, and how they're different. The sounds they make, how they act. It's this whole web of relationships, this geometric structure, that actually forms the blueprint of your reality. And here's the crucial part. This isn't just your personal blueprint. Research shows that this relational geometry is a core code in our cortex that we all share. It's like the underlying software that lets us have a common ground for perception to begin with. Now, what's really fascinating is where the stability in this system comes from. It's not our individual neurons. I mean, those can be noisy, they can vary a ton from one brain to the next. The magic is in the pattern. It's the relationships between concepts that form the super stable, consistent geometric structure that holds true for all of us. And this brings us right back to the first half of our opening puzzle. This shared, stable, geometric map of concepts, well, that's our common lie. It's the foundation, the common ground that allows us to understand each other and navigate the same reality. So that's how we build a shared map. But if we all share the same map, that brings up a pretty obvious question, doesn't it? Exactly. If the underlying geometry is the same for everybody, why does my experience of the color red feel unique to me, and yours feels unique to you? How do we get individuality from a common blueprint? Well, the answer is this really elegant idea from geometry called an orthogonal transformation. To put it simply, it's a way you can rotate something without stretching it or squishing it or warping it at all. All the internal angles, all the distances, the core geometry, it all stays perfectly the same. The only thing that changes is its orientation. And this is a brilliant illustration of what's happening inside our brains. Even though we all share the same fundamental map, your specific pattern of neural activation is like a unique rotation of that map. The core relationships are identical, but you're viewing that shared reality from your own one-of-a-kind neural angle. And there it is. That's the second half of our puzzle solved. The shared map is how we lie together. But that unique orthogonal transformation in your brain, that's why we can never lie the same way. We share the truth, but we each experience it from our own perspective. Okay, so we figured out how we can have both a shared reality and a unique experience of it. But that brings us to that second big question. What about that feeling of competence? Why does just getting things right feel so darn good? Well, it turns out that basically any complex system, whether it's a human brain or a sophisticated AI, has this fundamental drive to be stable and efficient. And to encourage that, they've got these built-in ways to reward themselves for functioning well. We call these intrinsic rewards. A fantastic example of this actually comes from AI research. There's this method called information gain-based policy optimization, or IGPO. It pretty much teaches an AI how to reward itself. Every single time the AI updates its own beliefs and becomes more accurate, it gives itself a little hit of an internal reward. It's literally rewarding its own growing competence. And our brains do something that looks strikingly similar. You know, we often think of forgetting as a failure, but neuroscience shows it's a critical, active process. Chemicals like dopamine help the brain actively trim away memories that aren't relevant anymore. This isn't a bug, it's a feature. The brain is constantly managing its own memory load to stay efficient, to stay flexible, and to stay focused on what actually matters. So that feeling, that soothing competence, is the conscious experience of this whole system working just right. It's your brain's own reward system telling you, yup, this is stable, this is efficient, this is working. It's the feeling of a well-oiled machine inside your head. Okay, we've covered a lot of ground here. So let's put all the pieces together and see the whole picture. This table just lays it all out perfectly. The idea of lying together, that's our relational coding, that shared geometric map of reality. The idea that we never lie the same way, well, that's explained by orthogonal transformations, your unique neural spin on that map. And that soothing feeling of competence, that comes from intrinsic reward systems, just like we see in AI and in our own dopamine pathways, that reward the brain for stable, efficient operation. And when you get right down to it, these two systems are deeply connected. You need that stable, shared geometric map to even have complex thoughts in the first place. And you need that intrinsic reward system to constantly maintain and optimize the map, making sure it stays coherent and useful. It's just a beautiful, self-regulating system. And that leaves us with one final fascinating question to chew on. If the fundamental architecture for understanding the world and for self-improvement is so similar in both biological minds and artificial ones, what does that really imply about the future of intelligence itself? Thanks for joining this explainer.
When you hear the word competence, you probably think about psychology, right? Or maybe skill building? Well, what if I told you the real answer? The fundamental architecture of what it means to be good at something is actually found in geometry.
All right, let's start with this quote. At first glance, it sounds pretty philosophical, doesn't it? Kind of like a comment on human nature. It hints that we can share a goal, a common ground, but our own personal experience of it will always be unique.
But here's the twist. What if this isn't just a deep thought about humanity? What if it's literally describing a fundamental law of how our brains work? A geometric rule that dictates how we, and even the AIs we build, create reality itself. Now that's a puzzle worth unpacking. Okay, first up, a blueprint for reality. Let's get into how we build this shared world in the first place.
I mean, seriously, think about it. Your brain is totally unique. Your experiences, your memories, your wiring, it's one of a kind. Same for me, same for everyone. So how on earth do we all manage to agree that a chair is a chair? How do we navigate a world that feels so consistent? It's a huge question, and believe it or not, the answer is all about geometry.
So the big idea here is something called relational coding. Your brain doesn't just have a file labeled dog and another one for cat. Instead, it maps them out based on how they relate, how similar they are, how different. This map defines dog by its distance to wolf, cat, pet, and so on. All these connections create this huge, stable geometric map of, well, everything.
And this is why this concept is such a game changer.
It's basically the essential code that lets us have a shared reality. By locking in concepts based on their relationships to everything else, our brains build this incredibly stable shared blueprint of the world. This is it. This is the geometric cornerstone that everything else is built on.
So if we're all working off the same blueprint, how come my experience is totally different from yours? This is where the second part of that quote comes in. We might be on the same page, but we're reading it in our own way.
And here we get to this beautiful paradox. The map itself, that geometric structure of reality, is invariant. It's stable, it's shared. But our own personal journey, our specific pattern of brain activity as we think and perceive, that's always unique. Shared map, different journey.
So let's connect this right back to our original quote. The lying together part? That's the shared structure. It's the invariant geometry that we all have. And the never the same way part? That's our individual brain patterns, our unique spin on that exact same blueprint.
Okay, you might be thinking, how is that even possible? Well, it's thanks to a cool mathematical idea called an orthogonal transformation. Just imagine you're holding a 3D model. You can rotate it, look at it from any angle you want. The model itself doesn't change, right? Its shape, its structure, it's all the same. That's kind of what our brains are doing, preserving that shared core geometry while giving each of us a completely unique perspective.
All right, next section. The feeling of rightness. We've got the map, and we've got our unique path on it. But what makes us want to follow the map well? What makes getting it right feel so good?
You know that feeling, right? When you've been wrestling with a problem and suddenly the solution just clicks into place? Or when you learn a new skill and it starts to feel effortless? There's this quiet, soothing satisfaction to it. Well, that feeling isn't an accident. It's a critical part of the whole system.
That feeling has a name: intrinsic reward. It's not about getting a gold star or a thumbs up from someone else. It's the system, your brain, or even an AI, giving itself a pat on the back for becoming more stable, more accurate, more efficient. Competence itself is the reward. This is the other cornerstone of the system. And we see this exact same logic in how some of the most advanced AIs learn, using a process called IGPO. It basically works like this. The AI makes a prediction. Then it gets some new data and updates its own internal beliefs. And here's the kicker. The reward isn't about getting the answer right. The reward is the increase in its own certainty. It literally gets rewarded for becoming more confident.
Of course, nature figured this out millions of years ago. In our brains, this self-rewarding process isn't run by a fancy algorithm. Nope, it's just good old brain chemistry.
And a huge player here is dopamine, but maybe not just in the way you're used to thinking about it. It acts like an efficiency manager. Get this, it actually drives the process of forgetting things that are irrelevant just to keep the system from getting overloaded. It's all about maintaining a smooth, dynamic, stable balance. And that state of stable, efficient operation, that is the feeling of competence. So let's put it all together. You've got this stable geometry and this internal reward for navigating it well. That combination is the very engine of competence.
You can think of it like this. That shared geometry, the relational coding, provides the stage. It's the stable, agreed-upon world we all act in. But a stage is pretty boring without an actor, right? That's the intrinsic reward system. It's the motivation, the drive to perform well on that stage. You absolutely need both.
So let's just quickly recap the whole model. You've got relational coding, which is our shared blueprint. You've got orthogonal transformation, which allows for our unique journey on that same map. And you've got the reward systems in both AI and us that create that essential feeling of rightness. These are the cornerstones.
And this is the ultimate takeaway. Every complex thing you do, every decision, every plan, your entire policy for how to interact with the world, none of it would be possible without this foundation. It's all built on top of a stable, shared geometry. And it's all fine-tuned by that deep, internal drive to just get things right.
So that leaves us with a pretty big question to chew on. If our minds and the artificial minds we're building are fundamentally designed around a shared map and an internal reward for navigating it well, what could we achieve if we really lean into that? What does that mean for the future of how we work together and for the future of AI? Definitely something to think about. Thanks for diving into this with me.